Alrighty, page 165 already. We're chewing through this fractions unit pretty good. So now we are converting between decimals and fractions, so switching back and forth. And I've been kind of prompting you with how to do this all year. So small little review first. There are two types of decimals. There's terminating decimals where they just stop. So for example, 0.5, 0.76, or 0.435. Okay, but it stops there. Then there's repeating decimals. So 0.333333333, and it just goes on and on forever. 0.454545, on and on forever, or 0.8111111 forever and ever. Amen. They never stop. So one of the first skills that you'll be asked to do this on this page is to switch between a fraction and its decimal. And again, I've been prompting you with this since I think the second day of school in September. Okay, you know, I'm always saying to you, what does this line mean? And you're getting pretty good at it. You know, you're always saying it means divide. Yes, so this means 4 divided by 11, and I wrote it out this way for you: 4 divided by 11. And if you do that, you get what kind of decimal? Yes, you're right, a repeating decimal. 0.36363636. And because it's the 3 and the 6 that repeat, this is how we would write it: 0.36 with the bar over the digits that repeat. Okay. Now, if we're going to take a terminating decimal and write it as a fraction, so if we had 0.3, here's the trick. There is one decimal place right there. Okay. So we're going to put it over a power of 10 that has 1 0. One decimal place, 1 0. So 3 over 10. So same number, except now we've got another power of 10. It's 0.03. There are 2 decimal places, which means we're going to use a power of 10 with 2 zeros in it. So this is going to be 3 over 100. And you're probably seeing the pattern right now. 1, 2, 3 decimal places. 1, 2, 3 zeros in our power of 10. So 3 over 1,000. And this applies to all of them. So like even if we didn't have a nice, neat, single digit number there, 0.33, same thing. There's 2 decimal places, 2 zeros in our denominator. So 33 over 100. 1, 2, 3 digits, 1, 2, 3 zeros. So 333 over 1,000. Even if you go bigger, 0.4567, there's 1, 2, 3, 4 decimal places. So we're going to put down a 1 with 1, 2, 3, 4 zeros. So 4,567 over 10,000. Okie dokie. Hopefully that's clear. So now they're getting you to apply some of this. So they're giving you a fraction. Sorry again. And asking you to put it into simplest form. So 0.365. So we see there are 1, 2, 3 decimal places. So we're going to put a 1 down and 1, 2, 3 zeros. 365 over 10,000. Then we're looking at it. 365 ends in a 5 and this ends in a 0. Well, I know my 5 times table always ends in 5s and zeros. So I'm going to divide by 5. And that gives me 73 over 200. And then we're done after that. You could continue trying to divide by 2, 3, 5, 7, 11, and 13, but all of them are going to come up as decimal answers if you try to do it for both, working for both numbers. So that's how we know we're done. This one, 0.0054. So it's going to be the 55 or the 54. So those 2 digits there over a power of 10 with this many decimal places: 1, 2, 3, 4. So 1, 2, 3, 4. Then same thing, lowest terms. First, we're going to start with our first prime number, 2. Divide them, I get 27 over 500. Then you could try 3. It would work with 27, but not with that. Or sorry, over 5,000, not 500, but I'm sure you can see that. And then we would go to 5, wouldn't work with that, so on and so forth. Eventually you'd realize, hey, that was lowest terms. Another skill, giving you a bunch of decimal numbers, some terminating, some repeating, and we're being asked to order them from least to greatest. So I just wrote them out again down the side. So 0.45 repeating. Let's write that out as it appears. So 0.4, or like as it would appear with the repeating, 0.454545. Then this one, 0.4, and it's the 5 that repeats, so 0.4, and then we see the 5 keep going. 0.4, it should just stop. I put a whole bunch more zeros just so that I had the same number of decimal places as our first two examples. And then another terminating decimal, 0.45. It should just stop there. But again, I put these zeros in. These are not necessary. I just put them in to make a point. Okay, so it did ask for least to greatest or smallest. Well, let's go checking. They all start with 0. So there's no whole numbers there. That doesn't help us. We'll check our first decimal place. They're all 0.4. So we don't know which is smallest or largest after that. So we'll go, by the way, this is the, if a reminder, tenths decimal place. Our next decimal place, hundredths. So we'll go to the hundredths decimal place. I see a 5, a 0, and a 5. Oh, a 0. Okay, so this one's the smallest. So, smallest one. Let's go to the tenths, hundredths, thousandths decimal place. I see a 4, a 5, and a 0. Okay, well, now I know going here that this is going to be my next smallest. That's number 2. Then up to these two, that one's a 4, that one's a 5. So I know this one's in the 3rd place, and then this one's the largest. Okay? So that's the end of the lesson. And as I'm sure you're hoping, expecting, and waited with bated breath, the joke of the day. Why is an equal sign so humble? Well, he knows he's not greater than or less than anyone else. Yeah, there's that much laughter in my household too, even though I have 2 people watching me filming this.
Wah, wah, wah.
Oh, I got the sad horn. Alrighty, bye for now.